Welcome guys. This is my first video in my new channel, Cloud Native Architect, and hope you will enjoy. You will learn something. Also, I will also learn. I will go step by step. So this is my first video from the design and principle in .NET software architecture. So let's start. So I think many developers who are already visiting this channel right now may know the solid principle, have used the solid principle. But in the interview or while implementing a solid principle in the project, sometimes people get confused, especially the juniors. So I'm trying to highlight few important areas that you already know, but if you don't know, please have a look in this day one channel. So what we have done, we have taken one problem statement. The problem statement is like the large enterprise system become a messy, right? Say for an e-commerce application, it has many divisions: order management, shipping management, payment, uh, warehouse. There's so many things, right? And you need to be very efficient in designing that e-commerce system or large enterprise system. And while implementing the system, before implementation, you need a proper design using solid and design pattern so that the design is scalable, maintainable, and as well as it can be upgraded to the newer stage, right? In case any changes comes. So it's very important that we first identify what are the things we need to do and what are the responsibilities are associated with particular areas, right? Otherwise, what you will face as the issue, harder to test, decoupling. If it is too much cohesive or tightly coupled, you cannot maintain it. You cannot involve multiple people to work on the same thing because it is tightly integrated. So many issues are there. Those who already have experience by 5 plus or 10 plus, they know understand what are the implications of not using solid principle properly. So we are trying to give a highlight what we can do. So we have taken an order service, the scenario. The moment user choose a browse a product, search a product, choose a product, and then the place the order. So order has multiple things, right? Order need to be upgraded into the inventory system, whether it inventory has the order that specific product or not. Once the order is placed, need to send a notification and also need to log also, right? What are the activities been done? What are the order number? Whom the notification has been sent, so that this logging can be used in a for troubleshooting or for auditing purpose. But you can see that from the diagram that client has a order API calling order service, and order service is so many things. Payment also, inventory also, emailing also, logging also. So the area is very specific. We have to handle the orders, but there are multiple activities within that area, right? Activities you have to pay. Once the order is placed, you have to initiate the payment call. You have to upgrade that inventory by reducing the item, or you have to check the item exists or not. Then you have to send an email to the recipient the order has been placed, and also you have to log the entire activity, who is placing the order, for whom the order is placed, and what is the product, everything. So in the order service, say API statement is fine when you're placing the order. But for the order service, you can see we are doing validate order, process order, update inventory. Everything has been written in the same place. So do you think any solid principle being followed? No. It is like a sequential programming kind of thing. And if two-person is working on validate and the process, other three are working on the update, send email, log, they need to be very cautious while merging the code and everything because it is in the same place. And in tomorrow, if need another activity to be added, the place of order need to be tested again because we are touching that entire area. So testing perspective, maintainability perspective, scalability perspective, there are a lot of problems. That's the reason design principle. What is principle? Some guidelines, some rule book, some constitution, which will help you to design in a proper way. Even if you do wrong, you can cross check with the principle, whether it is following or not. then you will be in line. So the rule we will discuss now. So the current architecture we already discussed, but you can see earlier in the order service we are doing many things. So instead of that, we are dividing. So client order service, single service doing everything that we already discussed, high coupling, low maintainability. Now we can divide the order API. We can use we can from the order API we can take three service: payment, inventory, and notification, which will be as will be a different services so that it can be managed independently with low coupling. So what we are doing right now, SRP, we are following single responsibility. Open close means open for extension, close for modification. You can extend it tomorrow if any logging service is required. You can add under as a logging service, right? So that will not create any problem for the payment, inventory, and notification. Many people can work on the many services, but the objective is only order placing. But many people can be involved in the service level, which is not possible when if you don't use solid principle. And dependency inversion principle will injecting these services, right, within the API so that it can be called properly. So refactor one, so the diagram already I have given earlier. The refactor one, client API, gateway, order API, payment, inventory, notification service, logging service, all will be a clean separation of concern. So what we have used strategy pattern, dependency injection, services abstraction. We will show you in a demo also. And the principle, solid principle, open close principle, and decoupling. So this is in the future. This is a day one video. So don't focus on this Angular React API management. We have just mentioned it will be part of that in the future. But right now we are focusing only on the solid principle. Once this implementation solid and we build something, then we'll do logging, retry, Azure AD, scalability. That also in the future. So the demo is, since it is a small demo, though I haven't written any code separately. So say for example, we are handling the payment, right? Say whatever I'm doing for the payment, the same thing happens for the inventory also, same thing happens for the logging also, same for having for the notification also. So iPayment service, we have taken exactly the what need to be done, where we will place the order. So order API will call the order service. Order service will call the iPayment service. iPayment service has been injected as a constructor, as a dependency injection, and it will call the process payment. Similarly, we can call I notification service, I logging service, or I inventory service. Okay, so we have given an example. So this is the way using solid principle like single responsibility, open close, dependency injection, you can achieve the loose coupling, high maintainability. And while explaining the solid principle, we implemented the strategy pattern also, right? So strategy why we have payment service, notification service. So tomorrow, if payment service also had three different service, right? It may be, that credit card, debit card, or wallet. So strategy is required. An abstraction. So this is the abstraction that the payment service will handle the payment related things. Similarly for notification and the other things. So hope this is clear. This is a very small video that how to use solid principle. Even if it is a small application or big application or the enterprise, you follow single responsibility, open close, and dependency injection, and then the design pattern like dependency injection strategy pattern. The whole objective is loose coupling, high maintainability. So hope you enjoyed this. We will again meet into the in a deep dive of the all the principle in the upcoming days.